Wind tunnel test. The goals and objectives of this case study are to use SoundViewer Pro to reconstruct the aerodynamically generated acoustic pressure field around a full-size SUV inside a wind tunnel, compare the reconstructed acoustic pressure maps on the driver's side window with CFD results, and examine the impact of design changes on the resultant acoustic pressure fields. The measurement microphones were positioned outside the designated boundaries to avoid any incidents caused by high-speed flows. Here is one example of the reconstructed acoustic pressure distribution on the exterior surface of a full-size SUV over 200 to 8,000 Hz frequency range. The airflow speed was 130 km per hour at zero yaw angle for the SUV. Results show that the most dominant acoustic pressure was at the driver's side window right behind the rearview mirror. The geometry and dimensions of the vehicle were specified by a CAD model. To examine the impact of design changes on the resultant acoustic pressure field, the slots on the rearview mirror were taped while all other conditions remained the same. Comparing to the acoustic pressure distribution under the untaped condition, the sound pressure levels on the driver's side window were reduced, and those on the A-pillar surface became the dominant ones. Next, the gap between the rearview mirror and A-pillar was filled, and slots on the rearview mirror were taped, while all other conditions remained the same. These design changes have reduced the amplitudes of the acoustic pressures on the A-pillar surface. Finally, the A-pillar surface was smoothed in addition to filling the gap and taping the slots on the rearview mirror, and other conditions remained the same as before. These design changes have further reduced the sound pressure levels on the driver's side window and on the A-pillar. The dominant acoustic pressure was now observed to occur around the front tire cover. Now we compare the acoustic pressure distributions reconstructed by SoundViewer Pro with those provided by CFD codes under the same conditions. Although the peak sound pressure levels provided by SoundViewer Pro and CFD codes agreed with each other, some discrepancies were observed. The most obvious discrepancies were found to be the sizes of the maximal sound pressure level. CFD computation predicted a large area on which the sound pressure level reached 110 dB on the driver's side window, whereas SoundViewer Pro showed a relatively confined area with 110 dB sound pressure level. Also, CFD predicted a large amount of turbulence eddies downstream of the rearview mirror in the field, whose sound pressure levels were much lower than those on the driver's side window. To see the corresponding acoustic pressure distribution downstream of the rearview mirror, let us look at the next slide. Here we reconstructed the acoustic pressure distribution over a horizontal plane across the midspan of the rearview mirror. Results demonstrate that the highest acoustic pressure level occurred at the corner right behind the rearview mirror and the driver's side window, and the area of this high sound pressure level was relatively small, which was consistent with reconstructed acoustic pressure distribution on the driver's side window shown in the previous slide. This slide shows the impacts of filling the gap and taping the rearview mirror slots on the acoustic pressure distribution on the same horizontal plane. Results show that the amplitudes of the acoustic pressures behind the rearview mirror were reduced, which was consistent with the previous reconstruction on the driver's side window. Next, we show the impacts of smoothing the A-pillar surface, filling the gap, and taping slots of the rearview mirror on the acoustic pressure distribution on the same horizontal plane. As expected, the amplitudes of the acoustic pressures were further reduced. Based on these results, we conclude that SoundViewer Pro can indeed be used to reconstruct the aerodynamically generated acoustic pressure field around a full-size automobile inside a wind tunnel. In particular, SoundViewer Pro can be used to assess the impacts of design changes to a full-size vehicle on the resultant acoustic pressure fields and the reconstructed acoustic pressure fields are consistent and make sense. Thank you very much for your attention. For more information, please contact Dr. Sean F. Wu at seanwu@signal-wise.com.